This is a VR headset simulator built in Babylon.js. It models the internal optics of a head-mounted display. You can adjust parameters like the focal length, lens spacing, and eye relief and see the results update in real time. I've added a feature to show what actually happens when your eyes don't line up with the headset lenses. So this can be seen from this slider that I've created, which is your IPD. So this will represent the user's IPD. So to bet so to better visualize this, so I've created this button here. So when you click this exit button, three things appear behind each lens. So firstly is the pink disc, which is the exit pupil. This is the small window of light the lens produces on the eye side. If you held a piece of paper behind a real VR lens while the display is on, you can see a bright disc appear in exactly this location. So secondly is the cyan box. The cyan box. This is where this is the eye box, the tolerance volume, where your eyes can sit and still see a clear image. And finally, the orange sphere is where your eye actually is. So right now, the HMD lens spacing, which is this IMD slider, is set to 65 millimeters, and your IPD slider is also at 65 millimeters. This represents this your IPD slider represents the real eye spacing. So since these two matches, you can see on the top left here that it is green, and it says that your eyes are inside the exit pupils. So you can see more information on the top left to show that everything is lining up. So let's show an example. So now watch what happens when I drag your IPD down. This simulates someone with narrower eyes using a headset that wasn't adjusted for them. So let's drag it down to maybe 55 millimeters. As you can see, the orange are sliding, the spheres are sliding outwards. So let's drag it down to 55-ish. Alright, so as you can see, the spheres are now sitting outside where they should be, and then the exit pupils are not lining up. So you can see that on the top left, it says that your eyes are off by 4.5 millimeters. So this is because the orange spheres are drifting away from the exit pupils, and then now this panel shows accurately how much your eyes are off by. So in a real headset, this person would be seeing blur and darkening around the edges of the image. This is called vignetting, and this is exactly why it happens, because their eyes physically cannot see through the exit pupil. As you can see, the exit pupil and the eyeball don't really line up. So the same thing works in reverse. If I adjust the headset's IPD slider to match the user, so let's say now I know that my user have a narrower eye space and I want to match it. So let me just move it down. So let me match it with 55. Yeah, I think 54 is good enough. But as you can see, uh, exit pupils move to meet the eye spheres, and everything goes green again, as you can see on the left. So this is what IPD adjustment on a real headset does physically. So the goal of this feature is to turn IPD from an abstract number into something you can see. The headset doesn't know your eye spacing. It can only configure to a value. When the value doesn't match your anatomy, your eyes miss the exit pupils. This visualizer makes that failure visible, and that's the whole point. So that's all.